This video is about the slope section of the Music Thing Modular Workshop System. So the slope section contains two identical units, which are both slew rate limiters. And what does this mean? Well, if we take an input signal, which is going to be the yellow trace above, and we take an output signal, which is going to be the blue trace above, then what a slew rate limiter does is the output signal basically follows the input, which is why we can only see a blue trace here because the yellow trace is hidden underneath it. But if I change the input rapidly enough, then the output signal takes some time to catch up. So the rate of change of the output signal is limited. And in a slope section, there are two LEDs, and the top LED lights up when the sort of target voltage for the output is greater than the current output voltage, and so the output is rising, and the bottom LED lights up when the output is falling, heading towards its destination, and when the output has reached the target voltage, the input voltage, and is just tracking it, then both LEDs sort of flicker like this intermittently. So this is what the slope section does when both switches are in the middle position. Let's look first at the left switch, the loop blip switch. If I press down the blip switch, then the output rises to a voltage which is about 8 volts higher than the input voltage, and that becomes the new target that the output is aiming at. So if I make a rapid change to the input, the output still takes a little while to reach it. But instead of tracking the input signal itself, then the signal that is tracked is about 8 volts greater than the input. Now I let go of the switch and it falls back to tracking the input. Now if I do that and rise the input voltage above 4 volts, then no surprises, because the output would then be going above 12 volts. That can't happen, and so any signals, input signals above 4 volts aren't represented there, but if they drop down below 4 volts again, we get that tracking in the output. So if I unplug the input, then unsurprisingly it's normalized to 0 volts, so we just get a 0 volt input, and that means that the blip switch is now just a switch that takes us from 0 volts up to something around 8 volts and down again. And if I toggle it periodically like this, so letting go of the switch as soon as the signal reaches 8 volts and pressing it again as soon as the signal reaches 0 volts, then really we're letting the output rise up to its target, but then as soon as it reaches there, we set the target to another value back down at 0 volts, and so on and so forth, and we get this sort of oscillator set up. Now this is exactly what the upper position, the loop position, does, except instead of being 8 volts greater than the input voltage, in loop mode it's 12 volts greater than the input voltage, and of course it loops automatically. Now what this does mean is that this oscillation, which if there's nothing plugged into the input is going between 0 and 12 volts, if I plug something into the input with a negative voltage, say -6 volts or thereabouts, we then get an oscillation that's bipolar going from -6 volts to 6 volts or thereabouts. What it also means is that if we increase the input signal while we're in loop mode to something that's greater than 0 volts, or just a bit more than that, what happens? Well, the loop output gets stuck at plus 12 volts because it's waiting until it reaches the kind of target voltage, which is whatever the input is, plus 12 volts, but it can't reach that because it can't go above 12 volts in a Eurorack system. And so the oscillation is paused while the input voltage is greater than 0 volts, and then restarts again when it's less than 0 volts. That can be quite useful. Now, the rest of the controls that we haven't yet discussed are the knob and the shape switch and the CV, and these are all about controlling the rate of change of the output. They don't change what the target voltage for the output is at all. So for the moment, I'm just going to unplug the input then, and we'll just use a 0 volt input, and I'll just use the knob and the shape switch and the CV to change the speed. So as we change the knob, this changes the amount of time it takes for the output to rise or fall a particular voltage. And so we get high frequency oscillations up to a few hundred hertz on as far anti-clockwise as possible, and oscillations down in the sort of minutes long on the rightmost side, clockwise side. The CV control, all that does is add on to the position of the knob. So the CV is a CV for this control knob. And so if in fact we now plug our input into the CV jack and turn that on, we can see that by adding a negative CV, we effectively turn the knob anti-clockwise and speed things up. By adding a positive CV, we turn the knob clockwise and slow things down. The total range of speeds available is a little bit greater than what's available on the knob itself. So, for example, by turning the knob fully anti-clockwise and adding negative CV, you can speed it up just a little bit more than what just the knob itself would do, but not by a large factor. Finally, we've got the shape switch, and the shape switch, when in its upper or lower positions, just sets either the rising edge or the falling edge of the slope to rise or fall about as fast as if the knob is turned all the way anti-clockwise. So that means that on these sawtooth or ramp waveforms, the rising or falling part of the slope takes about 1 or 2 milliseconds to raise sort of 5 or 10 volts or thereabouts. So that's the top slopes module. The bottom slopes module is almost identical, except that the response shape is different. The response shape in the bottom slopes module is exponential, and so slow this down a bit. If we just show this looping, rather than the linear waveform we had before, here the greater the output voltage, the faster the maximum slew rate up or down is, which means we get these sort of spiked waveforms. What it also means is that if we turn the frequency of this up a little bit, it means that the frequency of the loop mode is quite sensitive to the offset voltage that we apply. So if we now apply our control voltage to the input, if you remember, our oscillation is superimposed on top of this control voltage. But here, as we change the control voltage over negative CVs only, of course, because like the top oscillator, it stops when we get to positive voltages. But the oscillation frequency changes quite a lot over that negative range, and that can also be quite useful.